today. I mean, Professor Sergi Bermudez from the University of Madeira, well, my dear colleague, friend, former president of the International Society for Virtual Rehabilitation, who will talk. Well, I mean, you can just introduce yourself and go on. Thanks, Sergi.
Hello? Yeah. Okay, perfect. So thank you very much for the invitation, for having the great pleasure of opening this conference. My name is Sergi. I'm here wearing the hat probably of being the outgoing president of the International Society for Virtual Rehabilitation. And I'm going to use this opportunity, since it's the first talk, to talk a little bit about where we come from in virtual rehabilitation, and speaking about one case of work on cognitive rehabilitation, how we went about turning virtual some therapies for cognitive rehabilitation after stroke. So I'm going to start with a little bit of background. What is this area, virtual rehabilitation? Okay. And virtual rehabilitation is an area that basically denotes any use of virtual reality applications to support or enhance human function. And this can be through assistive technologies, this can be through rehabilitation technologies, or this can be through training technologies, such as the example we are seeing here, where we see a wheelchair simulator that's used to train wheelchair riding before actually having to use the physical device. Where we come from, this comes from the late 90s, early 2000s, okay, where this area started to appear. And this area, here I have an example to illustrate that, from the Rutgers ankle in the early 2000s, was very much centered around hardware devices, physical devices. And at that moment, for instance, physical rehabilitation was one of the areas of interest, and devices such as this robot here that would be used to train your ankle for rehabilitation were being developed. Now, this technology posed new challenges, which is how do we make a paradigm for training with these new technologies that we are developing? And there is where the first virtual environments and games for rehab sort of appear. Here we have an example with which you will control a plane with this robotic device to go through these frames. Quickly, what was natural is one device is way more versatile than just one single test. So here we have an example of the late 2000s in which, for instance, the group at the New Jersey Institute of Technology developed a suite of different mini games to be used with a haptic master, which is a device to use for the rehabilitation of the upper limb, in which they would train multiple functions. And quickly, these evolved more into software and content rather than devices themselves. The first companies appeared, such as the RX, that would use, let's say, early time augmented reality technology to embed people into virtual games for rehab. But the reality is today, we are in this exponential growth curve. We have over 1,000 publications a year in the area of augmented reality and VR in medicine. And by 2030, it's supposed to be a market of $20 billion. So this is something that's now really getting a lot of momentum, and the industry around this is building. I'm going to show you a systematic research we did to understand where do we come from, where we're going with this technology. So we researched any articles that had serious game, health, VR, AR, etc. on it, and we try to understand, okay, where is the effort being put? And with that, we reviewed 1,300 papers. Okay, and that's what I'm going to show you. That shows a little bit the state of the art. So what we see is that in terms of this technology, most of the efforts right now are going into gamifying and building games around VR. Okay. The second most important area of development is in simulations. Okay, simulations of real settings or training simulations, surgery, etc. And then the third area would be coaching, which technologies that help you through coaching into training a specific area. If we look at the areas of intervention, what you see here is a map of areas of intervention on these over 1,000 articles. The size of the sphere represents the amount of time it disappears, okay, and the connections if they co-appear in the same papers. So we see that stroke is by now the most researched area, okay, followed by fitness and then balance. But we see that the network of areas of application is huge, and it covers many, many different disciplines. So looking at the purpose of the technology being developed, we see that we have applications in monitoring, technology, treatment, rehabilitation, education, health and wellness, and training. But the most represented one is actually rehabilitation technologies, okay? And I'm going to present one of our works precisely in rehabilitation, the most research area at this moment. But it is really all about technology. And I want to make a clear point. This is not about technology. Technology is an enabler. And what it is about transformative and paradigm shifts. Okay? And I'm going to use one example to illustrate, okay, what I'm talking about. Since the late 90s, we know about the rubber hand illusion, in which we can induce the ownership of a rubber hand if we stimulate the real hand and a plastic hand at the same time, and a participant sees this, such that this participant ends up feeling the touch in the rubber hand, although knows perfectly it's a rubber hand. Okay, we know this since the 90s. Okay, but in the 2000s, this was reproduced in VR by the group of translators sitting here, and we could see that this illusion can be induced also in VR. Why is this interesting? It's interesting because this opens a potential paradigm for health that were not considered before. And this is one example by Kaiser, in which they used a full body illusion to induce body ownership in anorexia patients with different sizes and different body forms, such that the disruption and overestimation of their own body would be already affected after this illusion. So this is one example, but in all of these application areas, we have the potential of having transformative paradigms able to do what was not possible before through VR, okay? And that's what I'm advocating for. Paradigms, it's also about doing it. And I will talk about how we did one example, okay, for cognitive rehab and the different layers of design involved. Sometimes we may not consider them, but we are anyways taking the decisions on design in those aspects. So I'm going to take this example in which we have a person that's impaired, for whatever reason, has a problem interacting with the environment, okay? And therefore, technology is going to be there to try to mitigate and facilitate this interaction that's no longer possible the way it was before, okay? So the technology we choose to put in there, okay, is going to have a specific design, okay, with affordances and ergonomics. Okay, it's going to have virtual and physical interfaces that are going to bias and mediate any interaction between this person and the world. That's the first layer that we're putting in between, even before discussing any content. The second thing is, what's the context of these people? People live in different cultures, countries, different environments. Is this a person that lives autonomously at home? It's a person that lives in a senior house. It's a person that's independent, a person that's not independent. What are the goals? Wants to rehabilitate to be back at work and be productive again, or just wants to rehabilitate to be functional in the activities of daily living so that they can be independent by himself? What are motivations and interests? This needs to be considered as well. Then it comes to the training. When we develop rehabilitation technologies, what is it that we want to train? We have many things that we can train. Is it distal movement? Is this proximal movement? Is it executive functions, attention, memory? So how do we decide that? What are the parameters that are going to be used to actually challenge my patients? Is this going to be abstract, or is it going to be a realistic simulation of daily living? What type of feedback do we provide? Okay, we have the option to provide knowledge of performance feedback. Do I give a score at the end, okay, and they know I did well? Or do I provide knowledge of results, or knowledge of performance? I provide online feedback so that they can learn and improve while doing this. All of these are decisions we take. And then adaptation. Should I adapt my VR paradigm while they're performing the task? Should I wait until they complete that session and do it next session? Okay, those are questions that we pose when we develop a solution for rehabilitation. I'm going to talk about the particular challenges of going from traditional cognitive rehabilitation after stroke to a VR solution for it. Okay, so this is what traditional cognitive rehabilitation mostly looks like in the clinics. We are still using a lot of paper and pencil tasks. Okay, the first thing is paper and pencil requires motor control. Okay, to solve a cognitive training. Many times what we're using is neuropsychological tools that are designed to evaluate the status of participants to actually train them on those domains, which is not ideal. It's repurposing. They are very abstract. They lack ecological validity. So how does this relate to me going to the supermarket, for instance? They are no adaptive, okay? And there's a lot of knowledge of the professional built in there, how to use this repertoire of, let's say, more traditional tools. So we wanted to go from here to VR solution. I'm going to sort of go step by step how we went about this. So I'm going to try to go through these 4 different design layers. And I'm going to start with technology. The first thing is, if this is traditional training, and we know that using a pen as the mechanism to interact and to train cognition may be a problem. Why? Because in the particular case of stroke rehabilitation, we know we're going to have likely some motor deficits associated. Therefore, we're going to have what's called motor cognitive interference, where motor condition will interfere with the capacity of performing the cognitive training. So if these people need assistance to perform the task, okay, using a task that requires such a level of motor control may not be ideal, because we have muscle weakness, lack of control, spasticity, flaccidity, etc. So how do we go about this? Which type of technology? So one would say, well, I just use the handles of my VR device. Okay, my answer is no. Okay, we went through all the fancy technology and ended up with the most reliable technology that we know, which is this passive handle. Okay, this passive handle here has a simple large base that's going to help spastic patients stabilize. When they pose this on a tabletop, we'll correct the position. If they have flaccidity, we strap this, okay? And this can be moved on a table surface, okay? It's very simple, very cheap, okay? And works. How this works is basically then on the table surface, you move around your device, which is a passive device. It has a marker, and with a webcam, basically, you calibrate the active range of movement of the patient to the actual environment in the virtual reality that you need to interact. So somebody with a small range of movement will just have higher gains to be able to reach everywhere in the virtual environment. If we get this wrong, accessibility to content is already compromised, and anything coming after this is going to be somehow compromised because of this first layer of design. So sometimes what's around is not the most suitable technology. In this case, for instance, the handles of a VR setup. Second thing, the content itself, in the context. What happens today is we're reusing in the clinic a lot of crosswords that come from newspaper, puzzles that are not meant for these. Sometimes are even kids' puzzles or toys for kids, what infantilizes a little bit our elderly, that they are not kids, they are not infants, and need tools that are suited for them, or we reuse these neuropsychological assessment tools with them, okay, which basically have an inadequate design. So the idea here is this repurposing is fine because we have no other means, but with VR, we can develop virtual environments that are specifically designed to tackle those tasks that we want to rehabilitate. Okay, fully controlled environments. We can allow for minimally supervised training in which patients are more autonomous than performing maybe a puzzle. We can train a specific task we want to recover, individualizing training and providing lots of feedback for reward and motivation, which is something that's missing in conventional therapy, because feedback just comes after a significant improvement. And that can happen weeks, months after you start the onset of rehabilitation. Here, we can quantify and provide that feedback. We should take advantage of that. And then comes, okay, but what is it that we are going to train in the case of stroke participants? So we are here, this is traditional, but we want to do some VR stuff that's motivating, that provides positive feedback, that adjusts to the patient's abilities and quantifies performance, okay? But how do we go from this traditional thing to something that can be used in VR and still has solid roots on cognitive training, okay? Instead of inventing new paradigms and games, what we did was we basically started collecting everything that was around our clinical partners on cognitive rehab on paper and pencil. We identified 21 paper and pencil tasks. We sorted them by priority on their impact on activities of daily living, because we wanted to focus on function of transfer to independence, okay? And this rendered 11 tasks. Paper and pencil tasks, okay? Such as crossword, problem resolution, cancellation task, association, categorization, etc. Now, the thing is, these are fixed, these are paper and pencil. We have a problem, we want it to be adaptive. So how do we know how to adapt those things? So what we did was we tried to identify the number of variables in each of these tasks. For instance, in a crossword, how many words, how large is your area of research, okay? And then we created a number of permutations, up to 67 permutations out of the 11 tasks. And then we ask our professional rehabilitation partners to basically rate them for their challenges in attention, memory, language, executive function, and difficulty. And with this, we basically did some regressive models, okay, in which we ended up with a formula that related each of these variables to the challenges in attention, memory, language, etc. This is important because it will enable us adaptation, but we are still in the paper and pencil domain, okay? But this was quite useful, so we created this tool that we call the Task Generator. That is a web page, very simple, that clinicians use. You go there, you have your profile area, and you enter 1 to 10, what's the performance, the level of performance in each of these domains for a patient, and then you press generate. And it will generate these 11 tasks procedurally, every time different, enabling to have new content for training. So this is a cancellation task example. With one profile, you may end up with symbols unsorted, like this. You see that it has a challenge profile over there, where you see how it's challenging the patient. Or you can have with a sorted letter cancellation task, or even with a very densely populated number cancellation task, okay? And you see that this is excellent. Clinicians are using this because it's not disrupting their clinical practice, and it gives us models for adaptation. These we have free on our webpage, and we are happy that the clinicians from all over the world use it. It has been translated to Spanish, English, Portuguese, Italian. So we are very, very proud of this. But let's move on VR. So we thought we have this, so let's try the direct translation, okay, from this task into VR equivalent, in which we use that handle I showed to make this accessible with a VR representation, in which here you have, for instance, an example of a cancellation task where you have a number of target elements to find here. So we did this, we were very excited. This is how it works, okay? You have the patient moves this passive handle that moves a hand. There's action observation and mirror neurons things also considered here when we use the paretic arm, okay, for the training. And we said, let's compare to traditional training. And we did a study with 24 patients where we compared the impact of this, okay, VR technology with conventional standard of care treatment. And here we have an example of the result of the Montreal Cognitive Assessment, where you see highlighted impact. And what you see highlighted is positive impact, yes, in both groups. Okay? And then we have some different gains also in control or virtual reality. We see that there was overall positive impact in total cognition, recall, and in cancellation, that's attention. So we saw that actually VR is good, and we seem to have captured the essence of it, but it's not better. So what is it that we are missing? That was the next question. And the next question is easy to answer, I think, because the ecological validity of this training was still very low, because it was very distant from the day-to-day challenges that they have when they go, for instance, to a supermarket. So The next challenge was, how do we increase ecological validity in such a training? Moving, farther from those abstract tasks into something that's more realistic. And here it comes the RehaCity. That's our software in which we basically redesign the same tasks and the same models now in the context of activities of daily living in a day of the patient. So in this case, you would enter here the cognitive profile, the same models for adaptation go in the background, okay? And it tunes the challenges. And then you start. Here, instead of solving labyrinths with a patient task in a city, okay? Where you have things, you have signs, and we have some 8 map and arrow that we can fade out when needed. We go to supermarket, and then we have the cancellation task with the models and everything. They're embedded. It's the same, but it's not the same. This is a functional task that it's closely related to what they need to do in the daily life. Then they go to the bank, where they will get a simulation of the ATM and so on. So basically, those 11 tasks are now embedded in different activities of the daily living. Okay, and we think, okay, I think we're going to solve a little bit the ecological validity issue that we had with the previous training that was very abstract. What about adaptation? How do we adapt now? We know how to set the beginning because we do cognitive profiling, but how do we adapt this technology? We know that we want to have our patients motivated, because if they are not challenged, they will have a low interest, they will underperform. But if we stress them a lot, they will be under stress, the full performance will be low. We want to find that sweet spot that we also find, okay, in flow. We want to find the right balance between the patient's abilities and the challenge that they are completely engaged in the task, okay, and focus, and then we maximize patient performance. How to do this? This is very simple. What we do is we have the neuropsychological assessment, okay, that will set the baseline difficulty. This comes from the models I've shown already, okay? But how do we go from this? Well, then we execute one of the tasks, for instance, the navigation. We assess performance, and then we have this simple algorithm that basically says, look, if patients are performing above 70%, it means probably we are not challenging them enough, because we want them to be slightly challenged. Therefore, we're going to increase difficulty. If they perform below 50%, maybe we're challenging them too much, and then we just reduce the difficulty of the task, and we just go on this. So this is the insights of the RehaCity, how we came to develop it as is, and now I'm going to show you its validation. So we did a study with 18 participants, control, branch, and the VR group that would test this technology over a period of a month, 12 sessions. And basically, what we found here is very different from what we saw in the previous study. Here we were using the Edinburgh Cognitive Examination instead of the MOCA, but still a tool to assess cognition. And what we see is that in the experimental group, that's the VR, we saw statistically significant increases in overall cognition, orientation and attention, memory, language, and then executive functions, whereas in the control, the gains didn't get to significance by the end of the intervention. So we see that in this case, we had significant improvements, about 60% of all clinical ratings we had, and with spread gains in cognition, orientation, memory, language, executive function. And actually, when compared to the control did get these benefits, but only in follow-up 1 month later. So we accelerated the recovery by a month compared to the conventional therapy, which was very, very exciting. So to conclude this little journey from traditional to VR solutions, let me say a couple of messages here. I think VR and games can provide personalized, engaging experience we need to take advantage of. Low-cost solutions. This was a non-immersive VR solution, okay, that costs very little and can provide alternative rehabilitation paradigms. That's the key, alternative, things that we cannot do in the clinic. And we need to consider adaptation to both motor and cognitive abilities, both of them. Otherwise, we are going to be leaving out people from being capable of fully exploiting these technologies. A direct translation of what we do right now is not the solution. We need to shift the paradigm. We saw that when we basically translated cognitive training to a VR equivalent that wasn't making the difference, when we embedded ecological validity that made a difference. And then situating this task in a functional context of activities of daily living seems to be a good strength of using VR technologies. With that, I just want to draw your attention to the International Society of Virtual Rehabilitation, which is the community in which we work and meet around these topics. Okay, if you're interested, check out. Thank all people in the lab that do this. I'm just here pretending to know what I'm talking about, whereas they do all the work. And the partners, funding, and most importantly, all the clinical and end user institutions that work with us. Obrigado.
Oh, thanks, Sergi. It's amazing to see this work. We have some things to talk about apparently, but since we're like kind of behind the schedule, I suggest that any questions we leave for the coffee break. Will be later. We have one person waiting online, so I don't really want
to. I'm going to be around the whole conference.
Yeah, exactly.
So just find me and talk to me.
Yeah, you're easy to find, right? Okay, thank you, Sergi.
Thank you.
Our next speaker, was kind of busy yesterday. We spent the whole day preparing hackathon.